Hello! This is split into two parts. Part one's just about rigid objects, and the second part's going to be about skinned or moving characters or moving objects, because obviously I don't want the video to go for freaking donkey's ears. So if you're just interested in the other one, you can watch that when it's out. If it's out now, it might not be out now, might be out soon. I don't know when it's out. It might be out as I'm saying this. It might not be. It'll be out soon if it's not. But basically, this tutorial just covers using targets, looping events, and the new bind search feature. We've got a little billboard here, courtesy of Equipos. So we need a starting point for our mites and an end point. Right, so I've just got a tie icon where they can come from. Then it'll the billboard up, and then they'll piss off to this sphere. So now we'll create a TyFlow. First, what we'll do is we'll create one event for the billboard. So we'll do birth objects and pick the billboard. Now we can hide the billboard. Set it to geometry so we can see it. Now create our second event for the nanomites. So we'll just do a birth event. We'll leave it at 200, but we'll stop them birthing after, say, 25 frames. Position icon, pick the icon we want them to birth from, and then we give them a little bit of initial speed, 20 centimeters with 50% variation. Now they should shoot out actually. So we'll do it from the icon arrow, pick the icon, now they should shoot out. Yep. We'll make them large dots. It'll seem a bit easier. Alright. So now we have to give them a target. So we want them to target the billboard. As soon as these mites have spawned, we'll send them out straight away. The reason we send them out of this event is because I want them to loop in a different event, and you can't actually input anything from a birth event, so that's why we need to send them out. So now we'll do our find target, and we'll send them into here. Make sure the display is large dots again, and we'll give them a color that we can tell they're going to this event, so maybe like red. And now you can see as they come out, you can see they're into the next event straight away, but they haven't actually got a target yet. We can set to pick this object if we want. What that means is it's only going to choose one point. That's basically the one transform point of this billboard, but we want it to eat away the billboard. See, the mites come out, but they're not really they haven't found a target yet. So we need to set the target. So we'll add the set target in here, and now we'll leave it on channel target, but we'll do random. So now what it's going to do is it's going to look for targets randomly in this whole TyFlow system. Because in random we've set the channel to target, if we go to find target, and if we go down to target location, instead of closest, we'll change this to particle target, and then we'll change the channel to target. So now what it's going to do is it's going to look for random targets within this TyFlow system, and it's going to go towards them. So if I play it back now, you'll see it does some weird stuff. And what that means is it's randomly picking, because it looks for everything in the TyFlow event, it's looking for itself as well. So if we go back to set target and we go to target filters, if we click exclude this event, it means it's only going to look for targets outside of this event. Because we've only got one other event which has this one object in it, it's going to go towards that one object. If we then break this object up into fractures, say 100 points, so now they're going to go towards different pieces like this. I'm just going to up the points to say 500. So we want them to eat the sign away. We can chuck a delete modifier in here, and we can say, so when they find their target, we can send them into this event, and we can go delete. What that's going to do is that's just going to delete the mite itself, the particle itself. So we can actually pick target, make sure it's on the channel target. Now when it hits their target, it's going to delete the parents, just like that. Once they eat the targets, they sort of just go off into nowhere land, and they don't really do anything. When they've finished eating their target, instead of them going wandering off, we want to set a new target so they come back and eat something else. So therefore, what we could do, like we can, because we're sending the target into this event, we can script another event in here, but to tell them to do the whole thing again. So we could just make a copy of this whole event, put it in here. But then, you know, it's going to be, you change a setting in here, you have to change it in here as well, and it's just going to get a bit messy. So we can actually create a loop so that once the targets come out of here, we can send them back we can wait until they've eaten something, and then we can send them back into this target, into this event, to look for another one. So we can get rid of this event for now. And then the way to make a loop, because we can't actually wire this straight up to the same event, we can't actually do that. So a little trick to make a loop is just to use a send out. You can delete the display because we don't need that. And now we can just put them into this event, and then we can loop them straight back into the same starting event. If you just right click on here, you can add a point just to neaten it up a little bit. Just like that. So now what's happening is they're looking for their targets. Once they find it, they go into this event, then they come straight back again. You'll notice now they don't delete their target anymore. So we can add this delete. Where is it? So we can just add the delete into here, and now we can do the target again. In the find target speed, their velocity, I'm just going to increase that to, let's just give it, say, 20. Now if I play this now, alright, see they come in, they find their targets. Once they eat their target, they go looking for another one, and they just keep eating their targets until they've finally finished eating it. But once they go in to eat their targets, see how they all sort of like to come down here into the center point, to the origin? So they're doing that because if two of these particles share the same target, they're both going to go towards it. But if one gets there first, it's going to delete it. Therefore, the other one doesn't have that target anymore. And because it hasn't found it, it's not going into this event, so it's staying in here. Which means because it doesn't have a target, it's defaulting to go towards the center origin, because that's just where it goes if it doesn't have a target. What we have to do is we have to make sure that within this event, we want them to continuously look for other targets. So if we go into set target, we just change the timing from on entry event, we change that to continuous. Now they're going to continuously look for targets regardless. And what we can do is to save it from setting a target each time, we can do only set target if the current target is invalid. So we'll tick that. Right, so here we go. So now they'll come in, they'll eat all their targets, and once they've eaten it, they'll find a new one. Then once they've eaten all the objects, so we'll wait to see what happens when they eat all their objects. Right, so they've eaten all of them, and then once they've eaten all, they've no targets left, so they go straight back to the origin. Once they've eaten all their targets, we don't want them to go to the origin, we want them to go to their endpoint, which is this little sphere up here. We'll do a property test, and we'll say there's a test in here called has valid target, and I played around for this with a little bit, and I at first what I thought was I thought that there's a value. So what I thought was that the target's value is the target ID. So say this object here is like, say its birth ID is number 5, and the particle that goes towards it, obviously its target is birth ID 5. I figured that all their targets, all their birth IDs are all numbers above 0. So I did a test and said if the valid target is less than 0, then they should go into another event. But I thought my logic was right, but I just couldn't get it. I was like pulling my hair out trying to figure it out. So I emailed Tyson and he helped me out. So thanks for that, Tyson. And basically he told me that the valid target is it's only true or false, which means that 0 is false and 1 is true. Now, knowing that it's a Boolean value, you want to say if the target is equal to 0, we want to send it out and into another event where it targets this ball. So if we just switch this output sides for now, and we throw in another find target, send them into here, in our find target, we can just do pick objects and we'll pick the sphere. And we'll give these a little a color here to say green. Now they've finished their event. Give them large dots. So now, once they've eaten everything, they won't have any targets, so they'll go into here. And then that means they'll go to their end target. But you notice that if I play it back now, see how they're just going straight to the end? And that's because in their property test, and this is what I got stuck with as well, I forgot to set their channel to their target. So because everything in here is looking in their target channel, and all their targets are in their target channel, in their property test, we have to remember to set this to target. So it's saying if they have a valid target, if their valid target in the target channel is equal to 0, it means they don't have a target. So now send them out into this event, which makes them go find their little home over here. So there you go. So you can see they eat all their targets, and then they start pissing off home. Yeah, so that's pretty much exactly what we want. But obviously, the way they eat it up, we've got floating objects, and it doesn't look very realistic the way they're eating it. One thing I want to do first, I just want to fix up the movement of the particles. Say they're fine target. Let's give them a high velocity, so 50. And they're going to zoom towards their target really quickly and give it a variation of, say, 25%. They sort of overshoot it a little bit. We'll add a slow operator in here of, let's just leave it at 5% and see what happens. So shoot in, and they come to rest a lot quicker, and they start to eat up their things. Yep. Got to remember to in their final one, remember to sort of mimic these settings, just so they behave the same. And then we'll just shift drag this into this event, and then this last event now we'll keep the same settings. Let's just birth like 1,000, and we'll set it to stop at 50. And then we'll give the Voronoi fractures, let's make these about 2,000. Alright. And one thing that's happening as well is if we go under here, you can see they're going under the ground as well. So we'll stop that by adding a collision test in the particles, and we'll pick the ground. So now they shouldn't go under the ground anymore. Yep. The next step is to make this look realistic. So obviously, they're coming in, they're eating it away, but things are just floating, it doesn't look very good. So we want the billboard to react to these particles. We can give these bindings to bind them all together. So to do that, we have to add a physics shape first. You can see that they just fall. So bang. So we'll bind them together, and straight off the bat, the billboard's just going to fall over. So if we add the physics switch operator in here, we initially set them to kinematic, so they won't move. We're still not going to get that reaction we want. They're just floating. So we have to, instead of doing this check here to say when the particle hits its parent, it deletes its parent, we actually want more flexibility on what happens when it meets its parent. So we'll just actually we'll just disregard this one for now, and we'll do something else. So in here, we'll do a test. So we'll do a property test, and then we'll check for neighbors. So if we go neighbors, if it is greater than or equal to 1, then and it's within the radius of, let's just say 5 centimeters, just to make sure it works. So what happens is it's going to check for neighbors. So every single one of these fractures is going to check for a neighbor, and if that neighbor is within 5 centimeters, we want to send it into the next event, which activates their physics. Activates their physics basically. So I'll drag this into here. I'll make sure I set it to geometry. If I set it to a color, let's set it to a color of blue. As these particles come in, it's obviously finding more and more neighbors, so it's going to this event, but it's also looking for neighbors within itself. So we don't want to look for neighbours within itself. In the Nanomite particles, we'll give these a particle group. So in here, and we'll set their simulation. We'll change that to say, let's just give it group 1. So we'll say that the nanomites, their simulation group 1. And now in the property test, we'll only check for neighbours within the nanomite group, which is simulation group 1. So now if I tick 1, it's not going to check within itself anymore, it's only going to check within the mite group. So now, as the mites get closer, now it's checking for neighbours within the proximity. This is just another way we can get the mites to find their targets. So now that we've got them in this group here, we can now activate. So if we go dynamic and activate, now it's going to activate the PhysX. So now we can go through, and it's going to do some funny stuff because they're still all bound together, and some of them are kinematic and some of them are bound together, but they're still going to remain this. They're still going to stay bound, and they're not really going to do much yet. So we can break, once they're in here, we can break their binds. So we can go PhysX break, and now do break all. So now when it finds that neighbour, it's going to break its bind. As the mites find them, you can see they're all falling down. Whee! So now we have to delete them as well. So we can just go in here, in this same event, we can throw in the delete operator, and now we can either, instead of deleting it on entry, we can mix it up a little bit. So we can say on the event age, so when it goes in here, instead of just deleting it straight away, we'll delete it after, say, 20 frames, and we'll give it a variation of about 10, and now it's going to delete it randomly on those frames. So yeah, now you can see some of them are falling and it's really good, but obviously we've still got some floating ones. So we'll do another property test in here, and this time we're going to do a bind search. So if we go down, you can see this bind search. It's going to look through each one of its binds. It's going to return what's in its network basically. At the moment, it's all bound to each other. So if we go back into our binds, you can see that our bind settings, our binding ID is set to 0. So if we go to our bind search, untick particle binds, we make sure we tick it to PhysX binds. It's looking in bind ID 0. And depth is just how far it goes through the network to find, to do the bind search. But we don't want 0 because we don't want to look within itself. We want to actually look to see if it's connected to the ground. We'll add another bind network to our entire thing here. And now what we'll do is we'll set this to a bind ID of 1. And if I go down, instead of proximity particles, because we've already got a binding setting up for particles, now I'm just going to bind it to the ground. So if I do show bindings, it's a bit hard to see. You can see here, we've actually got some bindings binding these little sections to the ground. Actually might increase that to 1 meter, so 100 centimeters. Alright, now you can see we've really got all the binds showing up now. But obviously it's a bit too far because we don't want these ones here connected to the ground, because obviously they're not connected to the ground. So we've got to be careful of that. So we'll decrease that. Let's just leave it at 30 centimeters because I think that's enough. So now we've got our pieces that are close to the ground are actually bound to the ground with an ID of 1. So we'll go back to our bind search, and now we can say in our ID 1. So we can say if our bind search is less or equal to 0 in ID 1, it means that it doesn't have binds in its network that's connected to the ground anymore. So now we'll do the PhysX switch, and we'll turn it back to active. So we'll turn it back into here. Now we go in our display, make sure it's set to geometry, and we'll set this to say something like green. So now we'll know that if these get disconnected, we'll be able to see them turn green, and they should activate and everything that's not connected anymore should fall down to the ground. So you can see now, as the mites eat away these pieces, the purple pieces, it breaks the binds, and then all these huge chunks, so you can see up here in this top corner, this one here, this is all still connected together. Once it loses its connection in the network to the ground, it sort of says, oh, I shouldn't be floating anymore, so it goes into this event, which then makes it fall. So it just falls straight down, and now everything should work. Everything should work properly now. We obviously have to do this same neighbors test, so if we just we can just shift drag this into here, and we can actually, we'll bring this one out. Property tester go into here, and we can just send these ones out to go into the same event at the end. So now if we play it, everything should work as expected. So yeah, so they all go in, and they all delete all the little bits, and then piss off back. One thing we can do to make it a little bit better, when they sort of fall off, we can make it look even more like the mites are eating them by scaling them down. So we can throw a scale into this last event, set it to say 90%, and set the timing to continuous. And now it's going to continually scale these down 90%. So when they reach this last event, they're going to start scaling down. So it's going to basically look like the mites are sort of eating them up as they break off. So now they come in, they eat them, and you can see as the bits break off, they scale in. So it looks like they're getting engulfed even more by the bugs. But you might notice that some delete and it looks a bit weird and poppy. So we can even just we can remove this delete event now, and we can just say that we can do another test, and we can say now that we're scaling them down, we can say if their scale, so just pick one of their scales, if their scale is less than or equal to 0.1 on the scale, then we'll just delete them. Go into there and delete it straight away. So now when it's scaled down low enough, it will just delete itself. So scaling down, everything looks pretty good. Death to sign, death to sign. They don't look the best when they're all down here being a bit stupid. They're all sort of, they sort of just go, alright, we're done, see you, bye. Instead of sending them straight into this event, so they just all at the same time, because they all run out of targets at the same time, we'll do a time test, and now we'll put them into the time test first. Come on. Oh, I'm over here. I did it again. Oh no. Now I have to wait for it to load. Back to the start. Yes. Alright. So now they'll go into here, and we'll just make them hang around for a bit. So what? Let's do 30. Variation of 30 equal to, and then we will throw them into the last event. Right, so now when they get to the end, let's see what happens now. Let's see if it fixed it, shall we? So they come in, munch, 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 and then they piss off. Maybe they don't. Maybe they should go all back a little bit more. So I'll just change that time test here to say, let's just do 20 and 20. Hey, Tula für mich. Now it's just a matter of fine tuning all the settings. So you probably want more than 1,000 particles for the mites. So let's go. Let's do something silly like 6,000. Oh my god! In here, in the Voronoi fractures as well, you want these to be as small as you can. basically it's just as much as your computer can handle, I'd say. I'll go 20,000. Now we've got to change we've got our max fractures down here. We've got to change that to 20,000 to reflect the amount that we want. Alright, and with the fractures, remember in the fractures menu to set a material ID that you want the inside of the fractures to be. Right, so I've just added this force as well. So the particles are a bit static, they just go straight towards their target without it. So I just added this built-in noise, just set it to curl, and now they sort of do this sort of curvy sort of motion to their to the way they sort of come in, and just copy and paste that into all your following events as well. Ooh. Uh-oh. So see these little stupid things, like boom, this guy here going out into space. See you, bye. Wee. That's not good. So the way that I find is an easy way to avoid that is just go into your TyFlow settings. With PhysX, you can try increasing the substeps a bit. I just up everything by 2. And if that still doesn't help, go into the main settings and on the time step, set it to something lower. So like every half frame it'll do a test. This is going to slow it down the most, but it improves accuracy. So just fill around a bit until you find the right settings and see what's happening. And now it seems to play back. Everything's pretty accurate. Things are happening pretty good. The end, and then piss off back to their home. But yeah, that's pretty much it for doing some sort of like nanomites or something. I originally was doing it something to do with ants, and ants were going to go eat everything. Then I thought, termites would be cool to eat like a building, so you can do some termites. And I thought nanomites are pretty cool. So anyway, this was just the first little experiment. This is sort of more of an easier, more basic thing. So rigid objects like this, like the sign and stuff like that, they're really easy to destroy using this method. But stay tuned for my next video, because I'm going to do I sort of took this a little step further and sort of put it on a animated skin character to see what it looks like. So I'll probably do a tutorial on that next, just to show you about how some more advanced techniques that you'd have to use to get the pieces to work properly with the skin character and all that sort of stuff. But anyway, cheers, thanks for watching.